Welcome to another video from Mastery Tutoring. So today we're going to be doing analytical geometry, grade 11 and 12. So we are going to cover the following topics, which is the angle of inclination, equation of a line, equation of a circle with center 0, 0, or the origin, and lastly the equation of a circle with center A and B. So let us start with the angle of inclination. So when somebody talks about the angle of inclination, actually they are talking about the angle that the line makes with the positive x-axis. So this is in reference to straight lines. So let's define it properly here. So this is the angle that is the line. So normally, let's take three scenarios. Suppose you have your Cartesian plane that looks like this. This is our first Cartesian plane, and then this is going to be a second one. Make this one smaller, and then you have your third one. It's going to look like something like that. So in each of these, suppose you have the lines as follows, or as shown. This is your line there, and then this other one, suppose it is a negative gradient like that, and then lastly the other one, let's say again it is a negative gradient, but then goes in this way. So now this is how you indicate the angle of inclination. For this one, because the angle of inclination is going to be theta there, like that. So you draw this arrow from the positive x-axis, because it is always measured from the positive x-axis. So coming to the second one, you're going to put your theta here, and then you draw this. So remember, the angle of inclination is always measured from the positive x-axis. So now on the third one, this is how it's going to look like. We're going to put our theta here, and then we measure it. We measure it. So it's always measured from the positive x-axis. Alright, great. Now that we got that out of the way, let us look as to how you calculate it. Obviously, because these lines, they are sloping. So this one is a positive slope. This one and that one, they both have negative slopes. So now to calculate the angle of inclination, you need to know the slope of your straight line. So this is how you calculate it. You say tan theta is equals to y2 minus y1 over x2 minus x1, which is just the slope of the line. So you take the tan of the slope of the line, you're going to get the angle of inclination. So now there's something that you need to note from this. So you need to note the following. Number one is that if tan of theta is greater than 0, now then theta is an acute angle. Then theta is an acute angle. And then number two is if tan theta is less than 0, then theta is an obtuse angle. So these are the main things that you need to take and keep in mind for angle of inclinations. So let us proceed to the equation of a straight line. The equation of a straight line can be calculated from the following three equations. So the first one is going to be the one that we all know, y is equal to mx plus c. And then the second one is going to be y minus y1 is equals to mx minus x1. And then lastly, we can also calculate it from the slope. So m is equals to y minus y1 x minus x1. But if you look at this one, this it's actually the same as this one. It's sort of like rearranged this to get that. So it's basically the same thing. Okay, now so this is how you find it. So this is the general formula or the general equation that you're going to use to find the equation of a straight line. Now to find the equation of a straight line, we need the following. So we need number one is we need the gradient. So we need the gradient of the line, which is m. So m is going to be y1 minus y2, x1 minus x2, or you can say y2 minus y1, x2 minus x1, whichever the way you prefer. Alright, and then number two, what we need again is also the coordinates of one point on the line. So we need the coordinates of 1 point on the line. Alright, so if you have this, you're done. You can easily get the general equation, or rather the equation of a straight line. Okay, moving right along. Now we're going to talk about the equation of a circle with center 0, 0. So the equation of a circle with center 0, 0, this is how we go about it. So the general equation is given as follows. It says x squared plus y squared is equal to r squared. Now obviously the diagram now is going to look as follows. So this equation is applicable for questions that have the following diagram. So you see you have your graph, you circle them, and then we know that okay, these are our x's, so this is going to be your x, and then this is going to be your y. So the center is the origin, so this is the center there, the origin 0, 0. And then now we know that okay, the distance now from the center of the circle to a point on the circle, it has to be the radius of the circle. So maybe something like that. So this is going to be r, which is the square root of r squared is going to be r there. So basically this is all you need to know. So now to find the equation of a circle, you just need to know a known point on the circle. So to find the equation of a circle, I'll just write here. To find the equation of a circle, you only need 1 point on the circle. So when you get this 1 point, this is what you're going to do. You're going to take, suppose the point is here. Let's say, for example, for argument's sake, let's say the point is here, and then let's say it's 2 minus 2 and 5. So you're going to say now, okay, x is minus 2, because remember this is x and y. This is x and y. So you're going to say minus 2 squared plus 5 squared is equal to r squared. And then now you use a calculator to find the answer here, which is going to be 29. And then now we know that okay, r is going to be the square root of r squared, which is square root of 29. So your radius is 29. And then now you write the final equation. The final equation is going to look as follows. It's going to be x squared plus y squared is equals to, and we know that okay, r squared is equal to 29. So instead of writing r squared, we're going to write 29 there. So this is going to be 29. So this is all you need to know about the equation of a circle. This is simple and straightforward. Now let us look at the equation of a circle with center A and B. It's more like similar to what you do for equation of a straight line. However, there's some slight excuse me, it's slightly similar to what you do for equation of a circle with the center at the origin, but then there's some slight differences, just small differences. So to help you understand this, suppose we have a circle as shown here on our diagram. Suppose this is our circle there, and then now, but then this circle is drawn somewhere there. So this is the circle there. So obviously the center is not at the origin. So suppose this is the center there, and then this center is going to be A and B. And then now let me indicate the radius. So that's going to be our radius there, and then we put an R to show that, okay, this is our radius. So let's say we have a circle similar to that one, and then we know that, okay, this is the y-axis rather, y-axis, and then this is the x-axis. So now they can ask you to find the equation of a circle in such a case. The formula that you're going to use here is going to be this one here. So you're going to say x minus a squared plus y minus b squared is equals to r squared. So it's similar to the one that we used previously for when the center is at the origin. So it was like x squared plus y squared is equals to r squared. But then because now we've shifted this circle to the right of the x-axis, right? We're going to move. So we're moving in the x-axis. Therefore, there's going to be new center, and then also the y-axis. In this case, we didn't move in terms of the y-axis. We didn't move vertically. But in such case, in different cases, it might happen that maybe the circle is somewhere there. Let me just draw another random circle that you might have from this, just to further push the point that I'm trying to make here. Let's say, for example, this is your other circle there, and then this is going to be your origin there, and then this is going to be your R, like that. So obviously here you have new origin, or center rather. So this is the center there, and then in that case, that is the center there. So now to cater for all of these new centers, we introduce these coordinates. So the coordinates of the center are used to calculate the equation of the circle. All right. So now to find the equation of a circle, right, you need the following. You need the center of the circle. That's number one. Number two, you need one point, at least 1 point on the circle. 1 point on the circle. So let us take a quick example here. Suppose now we know that, okay, for this diagram here, let's say this point here is, okay, I've always been given the negative points. Let's take this point here. This point is going to be minus, say it's minus 2 again, and minus 3, like that. And then our A and B, let's say these are going to be minus 3 and 1. Let's say this is our A and B. Now we need to find the equation of a circle. So this is what we do. We start by saying x minus a squared plus y minus b squared is equals to r squared. And then now we substitute what we know. Let's start with substituting the values of a and b. So this is going to be x minus 3 squared plus y minus b is 1 squared is equals to r squared. So our ultimate goal is to calculate r. Therefore now we're going to substitute the coordinates now of x and y. So at that point, so this is going to be minus 2, and then this minus and minus will become a plus, so it's going to be plus 3 squared plus, and then the y now is going to be minus 3 minus 1 squared equals to r squared, and then now r squared is going to be so we have minus 2 plus 3 squared plus negative 3 minus 1 squared, and then this amounts to 17. Therefore, x minus, now here we're going to use this one here, right? So we're going to substitute the value of the coordinates at the center of our circle. So a, as we've already indicated there, is minus 3, and then with this minus they're going to add up, they're going to become a plus 3 squared plus, and then x minus, and then the y coordinate at the center of the circle is 1, so, and then we have 17 there. So this is our equation of a circle with center not at the origin. Thank you for watching. I hope this has clarified some of the issues that you had, and if you have any questions that you feel like maybe I need to cover, please make sure that you send them to us. And for those who are new to the channel, please hit the subscribe button so that you get notified and get updated whenever we upload new information. Thank you for watching. Have a lovely day. Goodbye.